So, hello, welcome for the first talk of today, Saturday. Yeah, it's always like okay, Saturday. First talk. This is Mykalin Jones. She will tell us something about Python teaching stuff. So you are a tutor. You are a former physicist. Okay, so and eventually people get to teaching other people, mentoring, tutoring, teaching children Python. Thank you very much. We really like this topic, as we do the same. So good luck, and please give a warm welcome to Mykalin.
Thank you, everyone. Thank you for coming this morning. So hi, yes, my name is Mykalin Jones. I'm the founder of Astro Tutors. Don't be fooled by the S, it's just me. But I'm very excited to be here at PyCon Slovakia. Thank you so much for having me. I'm super excited to be giving this talk. I've given it several times, but I've revamped the whole presentation for you guys. So it's the first time in this format exactly. I did a little bit similar back in November, but we're gonna have more examples this time. So if you've seen my talk before, then you're in for some new stuff. So my background is in physics. That's when I started off with Python. And then I got out of my degree. I didn't know what to do. And I started working with children because parents wanted me to. And I realized that I needed to write my whole curriculum to really fit what I thought was appropriate for them. So I'm going to be going over sort of anecdotal evidence for my pedagogical style. And hopefully you agree with me. But if you don't, I'm excited to know what you think. So I had to start off with these sort of misconceptions, if you will. Here you can kind of see what the media sort of says about, programmers and hackers and all that. To the left, you'll see what my mother wishes I would do. This is also what a lot of parents think they're going to get if they put their kids in programming lessons young, and what a lot of the adult career switchers I work with think is going to be easy for them to get. And I have a whole talk on adults where I kind of debunk that and also give them a lot of helpful advice. But today we're just focusing on the kids for the most part. This is what my mom and my friends think I do, and they are not wrong. And then this is obviously what we all actually do. Help me large language model, you're my only hope. And then there's what the parents think I do. I really have to mention what I frankly find to be a disturbing trend, where parents often quite obviously want to have some super genius child to show off. This happens more than you really think, and it's not all of them, of course. So we're going to start off today by talking about realistic expectations and methodologies when working with children. And just when it's appropriate to start, and what you can do in the meantime if they aren't ready to really sit down with a hardcore curriculum and start programming in Python. So I want to talk about some of the things that concern me first, because it's great to start on a positive note. So we should start children coding as early as possible, because it's like learning a language is the #1 line I see in advertising materials. And this really just gets me. Because we're going to talk about language acquisition and how it's similar and different to Python, to learning to code in a coding language. I won't go into it too much because I can spend way too long talking on that. It's very interesting. And just other marketing aimed at convincing parents to put their children in coding classes ASAP. I really want to take away that anxiety. We should really wait for when the kid is ready, and we're going to talk about when to know. And then this disturbing thing that happens a lot is what I've coined the Dunning-Kruger effect, the parentally induced Dunning-Kruger effect, where people think Dunning-Kruger is when you think you're more proficient than you actually are. It's the opposite of imposter syndrome, really, if you think about it. So what I get is children who think they're more competent than they actually are, because their parents take them through super complicated tutorials that are not age appropriate at all. The kid says, look what I made, I can do this, I already know this. And it makes them really unteachable, because they don't want to go over the basics that they really do need to review or just learn in the first place. A lot of parents will do these tutorials with their kids, and then they'll say, yeah, they've already done this. And the kid will be staring at me with these big eyes like, I don't know what we did. This can cause some complications, because parents will sit in on the lessons and then say, this is too basic for my child, which I guarantee you, if we're going over it, it's not. Children who are afraid to admit that they don't understand something is the most heartbreaking thing that I have to deal with every single day. The parent gets up, leaves the room. I say, do you understand what we've been going over for the past 30 minutes? And the child looks at me and goes, nope. And unfortunately, sometimes it takes 3 weeks, a month of forming a good relationship, teacher-child relationship, for them to feel comfortable to tell me, I don't understand. And I love it when they do that, because that's great. That's knowledge we have to know exactly where to start from the beginning. That's no problem. And then finally, the most concerning trend is just unnecessary screen time. This is a very personal choice for parents. It's good to talk to pediatricians, I always recommend. But there's a lot of research out there where we really need to be looking into how much screen time by age we should really be allowing. And I think that sticking your 6-year-old in a class where they're going to be staring at a screen when they could be, outside playing, I don't know if I agree with that really. So we're going to start with some things that don't work. Forcing kids into coding classes they just aren't interested in. You're going to put a bad taste in their mouth if they don't want to do it. It's fantastic when they're self-motivated, and I really recommend, doing some things to get them excited about it and then letting them sort of guide you. Pushing kids to do projects that they simply aren't ready for. So following these online tutorials that aren't age appropriate and then assuming they understood. And really just what we want to avoid is this picture to the left over there. I get parents coming in being like, can you teach my 8-year-old how to build a Django web app or something? And I'm like, how about a fun text-based game? And they're like, no. But we're not trying to build a CV just yet. It's going to be okay. I know the economy is rough, guys, but it's all right. Then a linear path, we're going to go over my pedagogical style and what I sort of believe in. But this linear path that assumes that they'll remember literally anything, I found, especially for the younger children, because they don't have the study skills to know to go back and review. I think it's really important to sort of consistently build on what you've learned and make sure you're doing that constant review. Removing the play from learning is just the worst thing you can do, especially for children with their attention spans like gnats. It's really important that you can have fun with it, and that's what I really try to do in my curriculum, and that's what I'm trying to do. I'm trying to build more, homework problems, but they're really like, here's a game to go and make and share with your friends. And I think, I do get a lot of parents who are like, this isn't serious enough, and that's very frustrating for all involved. So the big problem that I want to pinpoint is we're fixated on teaching children to code, or at least in my industry, the sort of for-profit educational industry sort of tries to say, oh yeah, code, because they want to profit. Let's be honest. I want to profit. I like money, but I don't want to do so, unethically, and I think that there is an issue with that. But I'd argue that we're asking most of the children, especially well before the age of 10, I don't teach younger than 8, if I'm honest, but we're asking, and then I modify it a fair amount. But I think that we're asking them to run before they can walk. And I think that there's so many things that you can have children do that really, develop the brain, develop cognition, develop problem solving. That doesn't have to be coding, and it's going to help them if they decide to become programmers later on. So when they're very, very young, you can start from day one, teaching them a foreign language, speaking multiple languages at home. ECM, I just couldn't fit early childhood music education. So my mother has a class for parents and newborns to bond, literally starting from day one, learning about rhythm and melody and harmony and all that. And there's actually a fair amount, a large body of research showing that this is very good, even for newborns, for brain development. Moving into puzzles, reading, art, developing those motor skills, that's really, really good for the brain as well. And then, moving into music lessons and all that stuff. And then you can get into typing, math, logic. I can't teach your kid to code effectively if they can't read, if they can't type. I think it's really important. One of the first things I do when I assess whether or not I can work with a child, we do a little bit of typing, and if they're, very much struggling with it, I assign typing problems before we ever get into programming, just because it can, we'll do some demos, and that's another thing that we can do that I talk about, but I really think that if they're at a certain age, so if they're, 10, 12, and they still aren't really able to type effectively, that's one of the things that we focus on, because that's an amazing skill to have later on. And then we can get into programming. And I really think that we can start at any age. One of the things that happens because we're saying, oh, we need to start early, I've seen a lot of adults who want to switch careers feel really discouraged because we're misappropriating programming languages for natural languages, and then they think, oh, I'm too old to learn this. it's not true at all. So don't get discouraged if you're an older adult career switcher and you want to learn to code. But also learn a language when you're older too. It's fine. So how do children learn? There's a lot of things that I think is good to take into account. So one of the first things is just observing. I think it's totally okay to spoon feed them information. I'm not the kind of person who's like, well, I don't know, you figure it out and tell me. I'm perfectly happy to give them as many demos as they need for it to kind of click a little bit. I try to keep the frustration less than or equal to frustration tolerance. So the minute you start getting to that precipice of frustration tolerance is when they start getting really disinterested. Once you get past that and they just really can't stand it. It's also something really important because I do sort of subspecialize, and I don't have any certifications, but I quite enjoy working with neurodivergent students, so people with ADHD, people on the autism spectrum. And one of the things about ADHD is you have difficulties with frustration tolerance. And so I do things during the class to really switch things up. So if they're really stuck, I'll take over and have them observe a bit. And so it's bringing back that level of how frustrating the problem is to something that's appropriate. And that's why every class, every course is bespoke for the individual student. Mimicry is a really good way to teach children. That's how they learn anything growing up. So I do this, you do this. And then exploring. Random play is absolutely essential. I do sorts of things where I think sometimes parents will be sitting there going, why are you doing that? The child will ask me something very, very ridiculous, like, well, what if we make this for loop go like 100 times as opposed to 10? We all know what that's gonna do, but the kids get a kick out of it, so I let them go for it. Anything that they just wanna try is really important. And then doing things to stimulate your senses. You might be wondering, well, what can we do in Python to stimulate the senses? Because we can't smell Python. But one of the things we can do is play around with Turtle. I think that Turtle is an awesome tool for teaching children. And this is also one of the things that we can do sort of where they don't have to be hands-on programming as much, but they can still collaborate. You can say, what color do you want the turtle to be? How many times should he move forward? How far do you want him to go? How much to the left? And so this is a way that we can sort of incorporate something visual. They can actually see how a for loop works, for instance, like we have up here. Something very simple, but they find it really, really fun and entertaining, and they can do all sorts with it. And then finally, I think that feeling safe, encouraged, and having adults who are excited about what they're learning is the most important thing. My students who do the best, their parents are in the room, but they're generally non-programmers who are sitting there going, oh my God, I didn't know you could do this. This is so cool. So that's always awesome. The kids really feed off of that, and I really love to see that when I'm working with a new family. So I'm going to skim over this part because I go into this in detail in all of my other talks. You can look up on like JingoCon Edinburgh. I gave a talk on this. But basically, I do want to debunk this idea that learning a language is like learning to code. The simple answer is no, but yes. So there's a lot of similarities as far as the skills it takes to learn anything hard. I think it's excellent to learn a language when you're young because you learn study skills, and that's really important. But, like with music, like with art, really anything that you need to repeat over and over again. There's some ideas of, syntax, grammar, communicating what you want to do. That's similar to kind of what we're trying to do in programming, of course. Learning important vocabulary, levels of fluency. So, you can be a certain level of proficiency, right, within a language or within a programming language. And then there's, repetition, practice, application, and abstraction. These are all a part of learning a language as well. But, really, I like to point out the learning mindset required and why it's great to start your kids off with a natural language when they're very, very young. But there are a lot of differences. Firstly, there's a really cool study. You guys can check out this link, basically where they show that it's not just activating the language center of the brain or activating the mathematical parts of the brain. It's actually activating this part of the brain just associated with anything difficult, like doing a crossword puzzle or something like that. So programming really is its own thing neurologically, which I find really fascinating. We haven't evolved to have like a coding center of the brain yet. But while learning, it's somewhat similar as far as just acquiring a new skill. So how we teach languages effectively may guide how we should teach programming, but actually how we teach programming effectively could guide really how we teach anything. So I think it's all related to each other. But I really do think that when children are younger, I don't like that we're emphasizing, oh, teach them to code. It's like learning a language. The younger you start, the better. Teach them a language when they're younger, because the language that you speak, or languages that you speak, influence, having a higher language aptitude later on. Better focus, actually, which is very helpful when you're trying to acquire any new skill like programming. Increased cognitive flexibility, so you have this code switching when you switch fluently between two languages or more, and it's correlated with mathematical ability. So there's a lot of benefits of being bilingual. I just always like to point out to people that you actually think differently and you solve problems differently based off of the languages you speak. But the main reason I like to point this out is I do like to emphasize it's really great when people have pedagogical materials in other languages and we can all share and translate. So I really like to encourage anyone who wants to work with people creating resources. All of my resources are free and available. And if anyone wants to translate anything, absolutely go for it. And likewise, I can help with English. All right, so before we get to this point, because we're talking about when they're younger, what can you really be doing? There's so many things that you can do. Providing puzzles, using real life situations. So I have these cupcakes over here. I've forgotten the word for the slot in the tin. I don't know if any of you know, but basically you can, as you're baking cupcakes with somebody, you can say, okay, while I have this amount of cupcake batter, I can scoop cupcakes out, right? For each slot in this tin, I can fill it with cupcake batter. So your language and how you're explaining things can help your child develop these sort of, this sort of logic, if you will. So there's so many things that you can think of in your day-to-day life where it really is just a for loop, something like that. But I think the most important thing and the sort of takeaway here is allow them to follow their own interests. The people I know who went into programming and were the most successful, they were self-driven. They started off with text-based games. They started off solving some problem in their physics class that they really wanted to program instead, something like that. So they took it and made it their own. So I think that if you let young children do anything that stimulates brain development, you're not going wrong. So I just want to take away that anxiety that a lot of parents come to me with of, oh my God, it's like learning a language and my child is already 8 and they haven't started Python. It's okay. That happens, I swear. You laugh. So when are they ready? I want to emphasize, I really don't teach younger than 8. I really prefer 10 years old. And I have to ask parents to really mitigate their expectations when they come to me. So I explain it, and if they aren't happy, I just don't work with them. It's fine. I'm not going to take your money and then act like I can give you a service that I don't think your child's ready for. But, if your child is showing genuine interest, I have a lot of 14-year-old boys, 15-year-old boys who really like video games, and they come to me and we start off with basic Python, we'll get into Turtle, and then we'll talk a bit about Pygame. So they have something that they really want to do with it. I think that that's fantastic. I'm always asking, people, adults and children, what problem do you want to solve? And then we'll sort of tackle it from there a bit. If they're asking what-if questions, so I think something that's really great is, barring too much screen time, but we're all sitting there, we're all programming. If your kid comes up to you and says, "Hey, what are you doing, Daddy?" Show them. And then if they're asking, well, what if you do this? Well, what if you do that? Or if you show them some simple code that's more age appropriate, and just tweak it for them. You can type for them and then let them sort of see what happens. And if it's an error, we get to go, oh, yay, we have a problem to solve. So I really try to take away that fear of that error message. But I think that definitely doing some little demos like this. So they're ready to work on their typing skills. That's really good, or they're already okay with typing is what I prefer before we take off with the Python. And I really do think that some math background helps as well. So I've yammered on about how people want to just teach their kids too young. But why should we teach them to code? I mean, this is a Python conference, for goodness sake. Of course, I believe we should teach children to code. But, I think it's great. They're like information sponges. It'll likely be useful later for them in life. It'll teach them resourcefulness and self-reliance. And it can also teach them teamwork. I think that it's fantastic if you can put, group classes together, and I'm working on putting my summer programs together right now, to have kids work together in groups. It can also teach them logic and problem solving, which is just always useful. And I think something that is really great is you can use it to supplement and reinforce coursework, and I'll show you guys something really cool later on you might be interested in. But I was really lucky that my calculus teacher loved to teach us to make little programs in TI Basic to solve our problems in calculus, and so I think that's a really good way to supplement what we're doing in schools, is bringing in programming and letting kids try to do their homework with some programming. So what do I focus on when I teach children? It ranges, of course, depending on age, but the logic of the problem solving, how can we tackle this? How can we go about this? Developing confidence in finding the answers. It's not about what you know. It's about, can you find out what you don't know? Can you ask the right questions? And then can you follow through and try to find a solution from there? Not freaking out if you don't know the answer. That's a great place to start. Self-motivation as well. So, I don't know, can you tell me? No. I want you to be like, all right, I'm gonna go find that out. So I think that's something really important that you can definitely foster as, part of their personality. Creativity. We make fun little stories. I'm going to show you guys some code snippets that we do to give you guys some idea if you don't want to hire me and you want to do this on your own, and then, good commenting. So this is one of my pet peeves because I once had a professor who didn't comment his code, and all of his variable names were like A, B, X, Y. I had no idea. And one time he sent me some code like this, and the only comment was, "This should be self-explanatory." So that's not allowed when I'm teaching. So we talk about, what should a nice block of code look like? Here's a full, readable comment with good variable names. I can definitely give this to somebody else and they can know what I did here. More importantly, a year down the line, when I look at it, I don't look at it and be like Gandalf, in the Mines of Moria, like, I have no memory of this place, which is more common. So my pedagogical style is I sort of draw on the spiral method. We start very, very basic and then do constant review whilst increasing the difficulty. So constantly coming back to those initial problems and doing a bit of review at the start of each class, and then incorporating that into today's problems. So we do demos to start off, which is just me showing them what we're gonna kind of be doing with the whole class. My first class is me just demonstrating what we can do. So for instance, I'll show them a for loop the first day, and then they'll change the number that we're doing. They get a kick out of making this 100 and having it count down, stuff like that. So I'm the one typing, but they're shouting out what they want me to do. Same with the turtle for loop, the different colors and all that stuff. Asking what if questions. This sort of goes into the demos. I'm doing the demos, and then they start asking a bunch of things. Well, what if you did this? What if you did that? And then we go, I don't know, let's try. And then I usually do know, but anyway, I don't want to give it away. That's the fun of it. So if we did 100, and then what happens here? Guided mini projects that are usually text-based games. So I had some kids, they make games, and then they take it to school and they show their friends, and they're very proud of that, and their friends can play their games. I think that this is just a great way to start off. It's not too serious, but it's a great learning tool. My favorite one is the choose your own adventure story. This is a really great one. You guys can try with your conditional statements. Which door do you choose? And then if the door choice is this, then this happens. And we keep going and going and going. And so this helps them also practice with how does indentation work in Python, things like that. They get a lot of indentation errors, and I have to sit there with it's horrible, but they really like it. And then, we review a short syntax question, stuff like fill in the blanks, to be honest. This is sort of at the start of the class. All right, what am I missing here? Don't forget that colon. Do you see how I indented here? And basically how would I get this, some output that I want. Then there's puzzles. So I actually quite like codingbat.com. It's a little bit out of date, but it's totally free. And it's really, really good for logic. I assign it to my adults, and as well as like leak code, stuff like that. It's really good for little short practice problems. So this is a really, really good one. I recommend you guys check out. This is a fun problem, but it's called Make Bricks. So we want to make a row of bricks that is goal inches long. We have a number of small bricks, 1 inch each. This was written by Americans. And big bricks, 5 inches each, return true if it is possible to make the goal by choosing from the given bricks. So this is a little harder than it looks and can be done without any loops. So it's a fun little challenge. I like this one a lot. And I think they have to use floor division for this one, which most of them are like, I don't remember you doing that. Yeah, I did. And then, we get into arbitrarily more complex problems that tie together more subjects. So we'll go back to their choose your own adventure game. We'll put in some F strings because F strings are fun and nice and Pythonic. And then I'll have them do a game loop or something like that, which is what you'll see in Pygame or something. You have a while true, and then the game will run until, you make it false, basically. So if I do some sort of exit key or something like that. So this is a good little way to kind of review while loops and stuff while sort of introducing a concept that they can use later on if they're interested in making a little game in Pygame. Some more examples. So we can, when they first start off with like F strings, multi-line strings, we do something called a code cake. This is not my idea, but I thought it was super cute. This is from the book Python for Kids. And basically you just make this multi-line string where they can make a cake basically out of any symbols they want and sort of like decorate the cake. And it's like a multi-layer sort of wedding cake kind of thing. And they have a lot of fun with that. Mad Libs are really good. A lot of people in the next generation, how old am I? They don't know what a Mad Lib is. So I have to show them what Mad Libs are. And then they go, oh, that's cool. So it's like this fill in the blank silly story. And we'll kind of do this with the input function, and then they'll be able to make a new silly sort of Mad Lib, but in Python. The random story is good, so they make a list of strings, and then using the random module, they'll randomly select an item from the list to fill in the blanks, and a story sort of builds on that Mad Lib. And then this turtle racing game is really, really fun. You have all these turtles on the screen here, and you can make them race randomly, and then go, oh, who do you think's going to win this time? Well, it's random. But we can actually change the parameters around to sort of make it more likely that one turtle is going to win or not. So they also have fun with that as well. And then for students age 14 plus, this is when it gets pretty cool, what we can do, really useful stuff. So we always go through the sort of basics like before, and the older kids really quite enjoy it as well. But then we can get into, Turtle I think is a good place to start, but if they're interested in games, it's not my sort of interest, but if it gets them excited, then I'm happy to go along with it and let them play. So we do a bit of Pygame, but for their science fair projects or something like that, use the PyData stack. Like it's awesome. And so we'll do a bit of pandas. We'll do some nice visualizations with Matplotlib, Seaborn, all that stuff. And you can really make some nice visualizations that way. And then over to the left here is something I'm really excited about. This is a calculator that you can program in Python on. So that's something I'm playing around with right now, and I'm trying to sort of write a curriculum or sort of a supplementary source of materials for teachers to use in their math classes and their statistics classes, science classes. It's a cheaper option for students who can't afford a computer at home, but maybe could afford an 80 to 100 euro calculator, and they come refurbished and used. And sometimes schools have grants to buy these Texas Instrument calculators. So coming from Kentucky, which is a relatively poor area in America, this is something that I'm quite passionate about, making all of this accessible. And of course, Python, we're an open source, free and open source community. And I think that that's something that, we can really make an impact by teaching people Python. So what about adult learners? You'd be surprised how many of them come to me and they're just so lost and confused. And then I give them my curriculum for children and they have all these aha moments. So I actually have this philosophy that maybe we're going a little bit too hardcore for the newcomers who are coming in from a non-technical background. So I have a very gentle introduction to Python. I change some of my wording around a little bit, some of the projects around a little bit, but for the most part, they're working with the same curriculum that my 8-year-olds are working with, and we just get through it probably a little bit quicker oftentimes. But if not, that's totally okay. I currently have somebody who's in his late 60s, early 70s, and he's just doing this for his brain, and he loves these little projects and stuff. But we're going very slow, and he's doing great. He's doing fantastic because he's very passionate, so he keeps up the practice. But yeah, I think a lot of adult materials are too frustrating up front. So if you guys are coming to this talk saying, oh, well, actually my girlfriend, my wife, my friend is wanting to learn to program, try seeing if maybe you're assuming a little bit too much about how easy it really is. So we all have to do a reality check when we're teaching these things. It might not be as easy as you think it is. So start slow and fun with some text-based games, things like that. But I definitely take a bit more guidance from their professional goals, of course. So if my interest and my main background is in data science. So most of the adults coming to me, that's what they're trying to switch into, data analytics, data science. And so then we'll get into working with pandas and scikit-learn and all that stuff. So I just want to leave you guys off on this one. This is my working draft of something I'm calling the Zen of Python education. I'm curious about standardizing our goals with education and what we think is good Python education. So something I didn't see in adult materials that I'm very passionate about always introducing and always mentioning to my children as well when they're ready is the PEP 8 style guide. So PEP 8 existed for a reason. Refer to the actual documentation and not some random website. Simple explanations are better than complex. Keep it nice and simple, give simple demos, everything like that. Complex, of course, if you have to be complex, it's better than complicated. You will have to repeat things. We can't all be Dutch, which is a reference to Guido. If you still don't get it, just give it a go. This is the one thing I teach all my students. I'm just like, just try it. You're gonna get errors, and that's gonna help you out. Start Googling, just go for it. Because they get into analysis paralysis, and then they just sort of, flop and go, I don't know, can you do it for me? And that's never gonna help them in life. So short, frequent lessons, in my opinion, are better than long. I get forced into, hour-long lessons with 8-year-olds. I think 30 to 45 minutes is really good. But, it's all about sort of gauging the child and seeing where they're at with their concentration levels and keeping those frustration levels appropriate. A good amount of frustration is fine. Too much frustration, they'll get burnt out and not want to do it. Long workshops definitely have their place though. So if things are more fun, upbeat, there's maybe some physical movement involved. So for the younger kids, then it makes a lot of sense to maybe have like a day of code, something like that. And of course, for the adults, we have like 3.5-hour workshops that I do. Programming is not a spectator sport. Get your hands dirty. So people just want to watch this. I say this about math. I also teach maths and physics. And I'm like, you have to do the problems yourself. You can't just watch somebody else code and know how to code. But YouTube videos are fantastic. I will say, I've noticed that there are some people out there who, when they're just getting started off, they decide to create content as a way to share what they're learning, but they don't say that they're learners. So do check out the comments, because people who really know what they're talking about will say, that's not the best way to do that. But the best thing about Python is our community. I've never seen somebody, well, I'm sure there are people out there, but I've seen so many nice people who will see a really egregious error, and it's somebody saying this is like a fact, this is the way you should do it, and they very nicely and politely say, I wouldn't do that, I would actually do it this way. So I think that that's the best thing about Python is our community, of course. Error messages are our friends. Don't freak out if you see all that red. And then meetings are one honking great idea. Let's do more of those. So I'm kind of hoping for more meetups for children as well, but meetups in general are great. All right, so, and I'm wondering what you guys think. Do you agree, really? And what would you add to this? All right. Thank you so much, guys.
Thank you. They were truly awesome, and we have a lot of questions. Yeah, I didn't expect that. So I will quickly start because we have only 6 minutes left. So at school, we typically teach children basics of all science, but when it comes to informatics, our children are taught Microsoft Word or PowerPoint. Is this also the case in other countries? Do we need to change something, or is there a country that we can get inspired by?
Great question. I'm not very sure about informatics in other countries. I do know that where I come from, education in America is based, really region by region, state by state, just area code by area code, because the funding comes from, the housing taxes. So the richer areas have computers. So not to make a political commentary, I have no opinions on that. When I was younger in my school, we did have PowerPoint and Microsoft Word and all these things, and that was really it. I remember she taught us, if your computer's not working, turn it off and on again. And that's how I got my first job in IT. But yeah, no, I do think that we need to talk, as a community about what should we be expecting, schools to be providing. And I'd be interested if anyone knows what certain countries are doing that you think is really, really good. Then that would be great. Yeah. Mm-hmm.
Thanks. We have an everlasting joke in Slovakia about teaching Turbo Pascal. Mm-hmm. So that works here all the time, like all these old teachers and young teachers, they always have they revert to Turbo Pascal that they teach all the time. Sorry about some of them. But that's here after Word and Excel. So the second one, I believe the biggest issue is to fight the social network influence. Often my teenage daughter asks, Dad, but what's the point? Everything's been invented. If not, somebody will do that next week. Let me scroll my TikTok feed. I struggle to find an argument to that. Any pointers?
Yeah, I'm sick of this argument. So I just want to be clear, and this is what I tell all of my students. Yeah, you can Google it, or you could have ChatGPT do it for you, but you have to have the expertise to know when what you're looking at is wrong. It's not the best way to do it. Furthermore, critical thinking skills, problem solving, is always useful. Okay, when I did my physics degree, I did a bunch of problems that had already been solved before. Why? Because I can do harder problems that haven't been solved later on. So it's never useless. And I just think that this is very silly. Everything is useful. If I'm learning Irish and people are like, why would you do that? Well, because it's a very, very different language from English. And I think it's fantastic for your brain, is one reason.
Learning by doing, yeah. That's okay. Let's continue. What about the visual coding? Visual coding, Baltic, Scratch, Turtle programming, yeah. We have something similar at our schools.
Yeah, I don't work with Scratch. I've heard it's an excellent resource. I do work with Turtle, and absolutely the visual aspect of that is phenomenal. It's very useful. I really want to put together a workshop teaching children to code with Turtle. So that's something I have in the pipeline. I think that if you're working with Scratch, if you want to work with Turtle, if you want to work with me to put something together, come and talk to me.
Yeah, okay, thank you very much. We have 2.5 more minutes. So I think the attitude of parents is crucial. Once when I was lecturing, a parent forgot to mute their mic, and he was very rude to his kid. It was sad. How do you work with parents, actually? That's the biggest problem, not the child. Children are fine.
Yeah. I mean, listen, it all comes down to, I ask to be paid up front, and I don't offer refunds. So I get control. And that's the way I think it should be, because I know I'm very good at what I do. I'm very reliable. I always show up. I always teach, and I'm always prepared. So people know what they're getting before they pay. But if they show up and they're really creating a learning environment that is not going to work for us, I do ask them to leave. And yeah, I do know if you're just standing there off screen, all right? Because your child has a totally different demeanor. Because I will have parents who will literally stand in the corner of the room and act like they're not there so that I don't know they're there. It's a whole thing. So no, it's really crucial. You have to stay positive. You can't just force your kid to learn something. But it's the way I work with parents is I'm direct, I'm respectful, but I have my rules, and they know before they start to work with me. And I do these talks. People come to me because they see these talks online, and they know my philosophy. And I'm very straight with people before we sign that contract and we start.
Thank you. Yeah.
Have boundaries.
Last question. Do you think Python is the best first programming language?
Of course.
Thank you very much.
Thank you.